Hey guys, I am Pranam Thakkar and I am going to give you the introduction for our project, temperature dependent water heater. So the main aim of our project was to develop and design a temperature dependent water heater which would keep the water in a desired range of temperatures, which is important for various chemical and biological applications. So for this we have used various different components like RTD PT100 temperature sensor, a water heater, relay module, Arduino Uno, which is used for the interfacing of the water heater and RTD PT100. So this is the PT100 temperature sensor, whose working principle is it measures the resistance across it. It has a platinum wire in it, whose resistance increases linearly with temperature. It has a fixed 100 ohm resistance at 0 degrees Celsius. So as the temperature increases, the resistance across it increases, and from the standard data table or data sheet of the of PT100 temperature sensor, it could find out the temperature accurately. The formulas used are as follows. These are the formula used. The resistance is calculated through the voltage which is measured across it, and the temperature is calculated subsequently. 0.385 here is the temperature coefficient of PT100, and 1000 used is the value of load resistance, and 5 is the input voltage which is given through the Arduino. So this is the relay module which we are using basically as a switch. This is a electrical switch which works on the principle of electromagnetism. It has a solenoid in itself in it. When an active signal is passed through it, a magnetic flux is induced. Thus the switch is on, and when as soon as the signal is turned off, the switch turns off, and the delay time is in microseconds, which is very less, and thus it helps in managing the circuit as a switch very efficiently. Here the active signal is when the temperature is less than 35 degrees Celsius. Thus it switches on the heater and the LED bulb, and when as soon as the temperature is reaches above 35 degrees Celsius, the switch is turned off, and thus it turns off the heater.
Hey there, I am Prayas Kulkarni and I will be explaining the working principle of our project. We are using a relay pin which acts as a switch. This is a RTD-PT100 sensor which measures the temperature in the water. So when the temperature as measured reaches a threshold which we have set to the mark of 35 to 40 the power to the heater. So currently we have dipped the heater into cold water, whose temperature we can see on the screen is at 20.18 degrees Celsius. So as it is less than the threshold, it should be the heater should be turned on, which is marked by the blink shown LED. Also, we can verify the temperature by using a thermometer.
Hello everyone, my name is Pranil Joshi and I am going to explain you the circuit. So here is our PT100 shown as a variable resistance. It has a resistance of 100 ohm at 0 degrees Celsius and it is taken as the reference. The 5 volt which is taken here is taken from the Arduino but shown here separately. This is a 1 kilo ohm load resistor, and across it we are taking the input. The voltage across the 1 kilo ohm resistor is given to the A0 pin, and we have written a code, and according to the code written, the Arduino calculates, does all the processing, and from the digital 13 pin the output is given to the relay, and the other end of the relay is connected to the ground pin. The relay has 3 pins, NC, NO and COM. The NO and COM are directly connected, gives the output, and are directly connected in parallel to the LED and the heater. The LED is put in parallel to the heater in order to show the state of the heater. That is, when the heater turns on, the LED turns on, and when the heater turns off, the LED turns off. Hello everyone, now I am going to explain the code for this project. In void setup, we are giving serial.picking 9000. This defines the rate at which the bits are transferred, and in the pin mode, we are giving digital 13, from which the output is taken. In the void loop, the input is taken from the analog pin A0 and given to the raw variable. Then this command calculates the voltage across the load resistance, and this command calculates the resistance of the PT100 and the final temp. In the temp variable, we are calculating the temperature of the system. The next command is stating that if the temperature is going less than or equal to 35 degrees Celsius, then we have to put the we have to turn on the relay, that is, which will indirectly turn on the heater. We are doing this as this is the motto of our experiment. Like if the temperature temperature of the system should lie between a given range, which we have defined here as 35 and 40. So between 35 and 40, the heater should not work. it will remain completely off, and if it is going below 35, then our heater should turn on. Hello everyone, I'm going to explain the results of our project. So the system which we are monitoring is this container in which water is filled. The temperature sensor is put in it, and here is the heater. As you can see, the temperature which it is calibrating is 29.68 degrees Celsius. So as the threshold which we have given, lower limit of the threshold of the buffer is 35. So the heater has turned on, as you can see by the LED glowing. So now the heater will start heating up the water slowly, and after some time we will get the system at a temperature much higher. So we can see that the temperature is 36.04, and thus, as we have shown, if the temperature goes above 35, the heater will stop. So after heating, the heater turned off at 35, but as it was very hot enough, the temperature which we are showing, has turned to 36, and it will gradually reduce. So thus this results show that the aim of our project is getting satisfied, that is, the temperature of the system is being constant, temperature of the system is being between 35 and 40 degrees Celsius.
Here, so I will be telling you all the challenges we faced while working with this project. For the relay module, it was a tedious task for us to know how it works, the input pins and the output pins, and how to connect it across the heating element. The second challenge we faced was with the RDD sensor. The data sheet we have to find, and then we have to find the conversion formula from resistance to temperature to get the temperature reading. So while we were working on our last project, we were encountering this error again and again. It is showing the ALSA library is not here. When we tried to download it by writing all the packages inside ourselves, then also it was showing this. So I think it is a problem with the Raspberry Pi model which we are using. We have completed all the setup, but we are unable to rectify the error. That's why we changed our project.